Well, thanks everyone for being here. My name is Mohammed Awad. I'm the VP of the IoT and embedded business at ARM. I hope everyone's enjoying Startup Day so far, and I want to thank you guys for all joining us. I'm really excited to be here today. I've got a bunch of ARM partners. We're going to share their perspectives on technology, tools, and skills that are required to help hardware developers and software developers, innovate and innovate quickly. I personally believe that, by bringing together the hardware development environments, and software development environments, and integrating those together, getting those two groups of developers to work more closely together, we can accelerate, IoT deployments, we can accelerate innovation, and we can create a lot more leverage, especially in the IoT and embedded spaces. But let's get right into it. So why don't we start by asking, each of our panelists to, give us a little bit of a background, who you are, where you work, that kind of stuff. And, we got the Zoom lottery here. So I'm going to start with the first person in the first box in the upper left-hand corner. Gopi, why don't you kick it off for us?
My name is Gopi Siraneni. I'm the CEO of the company. First of all, thank you to the ARM and everybody at the ARM team and Mohammed and everybody for us to be participating in this one, Axiado. I'm proud to be representing Axiado.
So Ramin Shivani, I've been in Ethernet business for over 25 years, multitude of companies. Enable Semiconductor, I sold it to Lucent, and Quantia was the last company when IPO. Started Ethernovia with my colleagues 3 years ago, and we're really focused on virtualizing Ethernet communication and vehicle communication.
So I'm Marco Ciaffi, VP of Engineering and one of the founders at Dover Microsystsems.
Hi, everyone. My name is Yodit. I'm the CEO of OpenSensors.
Hi, so I'm George Gray. I'm CEO of Foundries.io, previously CEO of Linaro.
Hi, thank you for having me. This is Sriram here. I'm Head of Systems Engineering, heading 5G Architecture and Design at EdgeQ.
One of the things that we think about, me and my team think about quite a bit here at ARM is, how do we enable software and hardware to work more cohesively together so that you can accelerate time to market and make it easier for people to innovate and develop, amazing products. We sort of feel it's our responsibility within the ecosystem to kind of drive that. And it would be really interesting for me to hear from you guys as to, what do you think is standing in the way of hardware and software development happening more cohesively? What do you think the biggest challenges are? What do you think is standing in the way of that? George, why don't you kick it off for us?
Oh my goodness. I think if you look at the history of embedded software over the last 20, 30 years, it's kind of scary that we're still doing everything from scratch ourselves, and even in some areas, some of our vendor SDKs are Windows only. And here we are now in an era where it's cloud engineering, right? We have to move to integrating software development and hardware development and product deployment and security. And we can't do this one product at a time. So I see a lot of the challenges in changing the way we've traditionally worked. And the ARM ecosystem is amazing because it brings together all of these companies who are innovating in different directions. But the challenge is they're all innovating in different directions. And so how do you actually have a platform that everybody can use to build and deploy products more easily? And that's something we're trying to address with Linux, but it also applies across the industry from microcontrollers and in market segments, microcontrollers to very advanced SoCs used in autonomous cars, and everything in between. So I think there's some huge challenges in simplifying the development of products so that they do become more secure. And to be honest, there aren't enough security experts to go around. We need to solve this problem.
Yeah, I couldn't agree more with you. To think that embedded developers still have to deal with jumpers and cables and boards on their desk, and every time you go to a new platform, it's all you have to start all over again is crazy when you think about how development happens in other industries. Sriram, what do you think?
Yeah, I mean, especially, I mean, in the wireless network, right? A lot of progress has happened, but let's just look at what has happened over the last, maybe few decades, right? Traditionally, any wireless network essentially has been a hardware platform and some specific software running on it for a very specific application, which is just 3G or 4G. Then you rip it all apart and then throw it away and then restart again. So it's always been very rigid, very inflexible, not very conducive for any innovation or any changes. But there have been, major tectonic shifts, as was just now alluded. Migration to a very cloud-native model for almost everything in the wireless network, as well as a full disaggregation of hardware and software. Right. So at EdgeQ, our approach to this is essentially look at hardware and software in a sort of holistic manner. And there is always going to be a sort of a balance point, because you do have some traditional hardware acceleration in this domain I'm talking about, and you need to bring in the software flexibility. Going forward in the wireless domain, it's not just about one specific application. There are many applications all being encompassed into the same platform. So we need to be aware of this sort of fragmentation, diverse market. Each comes with its own sort of, QoS requirements and so on. So we have to sort of make it softwareize everywhere, right? But at the same time, some functionalities need to be sort of hardware accelerated, encode, decode, so basic functionalities on bit processing and so on. So there has to be a balance, but it is essentially more and more becoming software driven as we go forward.
Excellent, excellent. Yeah, I agree with you. One thing that occurred to me is I think both, George and Sriram, you're really talking about higher end systems, what I'll call higher end systems running, Linux and kind of, or some higher level operating system. Yodit, I assume that some of your products are maybe more focused on, lower end devices or, more, resource constrained devices, I guess. What do you think is standing in the way of that hardware software development happening in a more cohesive way down on those devices?
I mean, I agree with everyone's points, but also, yes, from our side, we are, usually deploying in one site, 1,000+ sensors, and they are very much low level, kind of built on top of the LoRaWAN stack in terms of networking. And what we found so far, at least, has been a lot of the companies are just staying within their sphere of comfort and not necessarily thinking about how they integrate with the wider ecosystems. And companies like ours, who are very small and not necessarily have all the people and expertise in the world, have to come in and figure out how to do the systems integration.
Yeah, it's interesting because we often talk about the challenges associated with the hardware development and within the ecosystem, because that's the kind of the first step as an IP company where we engage. But more and more we're seeing that it's the challenges in software that are really revolutionizing the way we think about hardware. And I guess I'm curious as to for the panelists, like, what are the challenges that you're seeing in these software driven systems and how they may be impacting or changing how we think about hardware? I don't know, maybe I'll pick on you, Marco, ask you to kind of comment.
Yeah, so in our case, we live at this intersection of hardware and software. At Dover, we're actually not only developing complex software, but we're simultaneously developing complex hardware, which can be architecturally have architectural implications by the software itself. So this desire to have these highly configurable systems, especially when you're developing both ends of that for small startups like us, we're an early stage 17-person company, is extremely challenging. So finding ways to be able to maintain our agility, maintain our efficiency, maintain our speed, and still be able to satisfy all of our requirements. Now we've got more than ever these requirements that on day one, when you're shipping your hardware, you want the entire software stack to be ready there, available for you. So this integration and more and greater cohesiveness of the software teams being integrated and involved early on in the development of the hardware is more important than it's ever been before. So figuring out ways for us to be able to do that, and do that in a resource constrained environment. And by that environment, I mean the corporate environment, where we can't just go out and hire all of the talent that we want. That's really a challenge that I'm seeing right now, and that we live every day.
Interesting. Yeah, we all live those challenges. I completely agree with that. Raman, Gopi, anything to add to that? Or?
I can, so let me just give you the example of the world that you talked about, how the software is driving the hardware in here. And if you look at the last decade, everybody talked about AI, and AI stuff is going up. So everything is becoming an inferences and a TensorFlow, compute engines. You need to put a lot of compute engines. What happened is then the hardware is not there to meet those demands, and the only company actually doing the market is an ARM. Gives you like an M series, A series, etc., to give a partition to the world of, okay, you can pick the one, two, but you will never have enough thing compute to when the software reached out. That's why last, 3-4 years, there's around 80+ companies of hardware companies and AI companies to start building up the ground up, completely building to meet the demands of compute power needed.
These challenges are very obvious and centerpiece in the automotive industry today. As you know, a vehicle, with the complexity it has, and with the push to have it be a software-defined vehicle, has many disjointed set of software development. A vehicle may have as many as 100 to 200 disjointed, software development. And on top of that, right, the complexity of the hardware and the validation required, pretty much 18 months past, getting some silicon and validating the software, and the cycle time involved with multiple tiers of, hardware software development in automotive, from OEMs to tier 1s to tier 2, it's just not scalable, right? These challenges are front and center, and we already see, many car makers, OEMs, and tier 1s kind of reorganizing to try to address these challenges. For us as Ethernovia, right, working hand in glove with these OEM and tier 1s, sitting at the edge of software and hardware, so we can innovate by being hardware experts, being silicon experts, but at the same time understanding the software challenges such that we can solve it in an elegant and innovative way. And that's what we've done in Ethernovia, is solve it in a way that we create, as an example, software protocol offload, right, in the form of adding additional hardware to our circuitry. And again, another example of solving it would be to use what industry calls digital twin. I'm sure you guys have heard of that. And prime example of that in automotive would be the digital twin models that we've developed for PAVE 360 from Siemens, and ARM has developed for the same platform, which kind of gives the developers, the designers of the car, a very early, head start in designing the hardware, validating the software, and really cutting this cycle time of 7 years to something much more manageable of a few years, right, of 2 or 3 years. So we absolutely dead and center for this automotive industry. These challenges are being addressed, and Ethernovia and our partner ARM is in the center of it.
Yeah, the automotive industry is really interesting because they sort of exacerbate a lot of the challenges that we're seeing in other industries because of this, the things like the qualification cycles and the complexity of the hardware and the software and those systems, just the overall durations. But I mean, I think the trend that I think Marco and Gopi and Raman pointed out was really about a couple of things. One, it's just the idea that the hardware is maybe not ready for is not ready when the software development needs to start, which is part of the problem. You got to wait for that hardware to be available. And then I think just the diversity of the underlying hardware makes it complicated in order to kind of leverage those software investments across lots of different devices. I think those are the two main themes. I'm curious, and maybe I'll ask George to comment, as to kind of, how do we think as an industry we're going to overcome these challenges? Because these have been around for a while, and there's different ways to kind of go at it. But I'm curious as to kind of what the panel thinks.
Yeah, I mean, there are some really interesting initiatives going on in ARM, particularly to try and help the ecosystem work more effectively and efficiently together. And this is around, how do you abstract the low-level hardware differences in one SoC security infrastructure from another? How do you create common APIs, and how do you make it as easy as the server spaces, where you have a hardware specification and every operating system runs on every server, right? And obviously in the embedded world, it's completely different because everybody wants to build something different. But some of the initiatives around what ARM is doing with Project Cassini, with System Ready, to try and effectively abstract the hardware differences from the software platform. And then what we're seeing in the high-end embedded devices, not necessarily automotive, this applies to robotics, industrial sensors, even low-end gateways, is a separation of services and applications being built using container and virtualization technologies, and completely separating that from the low-level operating system and networks and security platform and so on. And in this way, software developers can actually start on completely different hardware, build containerized applications that can then be run on a variety of different hardware.
Yeah, absolutely. And what's interesting about what you said, and it's true, Project Cassini and some of these other standards are off kind of working on some of these problems. But I think, what we're finding more and more is that, one of the big requirements for those initiatives is to not only standardize in some way how software interfaces with the hardware. That's almost the easy bit. The more difficult bit, and this is what we're really focused on, is preserving that underlying differentiation of the hardware, because that's what makes the ARM ecosystem so special, right? Is, you've got this broad marketplace where people can go innovate and create all sorts of, one of our architects likes to call it weird and wonderful hardware, right? Yoda, anything to add to that, or what's your view?
Things like the abstraction layer, once that stabilizes, what that brings in is, version control. If you have the containers of your and easily deployable, and then you can roll back, and a world of kind of possibilities open up. Because right now the nightmare is we have, I suppose, historical deployments that we've done over the years. We're trying to update hardware, new manufacturers come in, and so on. So there's a lot of innovation that's supposed to happen, but the maintenance is such a pain, and we have to be so careful, because a lot of, for our deployments and probably for most companies and developers, you're not going to be able to physically touch your assets. So maintenance, and even at our age, at six years old, maintenance is a huge issue. We have to make sure that we cannot break the existing, but also innovate for our clients going forward. So that balance is already becoming kind of a technical debt in a way, and that really needs to go away.
Typically, historically, folks that are developing their hardware will develop their hardware, have some conversations with software guys, but they're developing their hardware. Eventually, they hand off this hardware. Software guys need to deal with that. Analogously, the software guys are busy solving their problems, writing their applications, testing them on existing hardware. Well, here comes the new hardware down the road right behind it. So that's always been a challenge. In our case, or in many cases, if you're really at this intersection of hardware and software, and you are developing both, one of the things we found really needs to exist and be stronger to address this challenge of being cohesive and co-developing both sides is tooling. We've found that there are few areas where we can actually find platforms that allow us to simultaneously develop software. That's a real game changer, I think, is making better tools to enable the small guys that are really trying to develop something that's complex on both ends. That's one thing. Another thing that we haven't touched on yet that I think is very important and that we're trying to make use of is incubators and partnering. There are certain things that we're talking about startups, right? Startups just can't afford the expensive tools, can't afford the expensive hardware. Big companies won't necessarily talk to us, but you've got players like Silicon Catalyst, they're also participating in Startup Day. They'll have an ecosystem of in-kind partners like ARM, like other big players that basically will provide services, technologies, and even access to very low cost, if not free, shuttle runs for silicon.
So yeah, so a lot there at the intersection of hardware and software. I mean, I guess the question that I have is, at this point, who do we think's leading us into the future? Is it going to be the software architects? Is it going to be hardware designers? Is it more of a partnership between the two? I mean, what's the consensus here? Sriram, we haven't heard from you in a while. What do you think?
I think it's both, because what we require from the hardware is different than what we required before. I would say it's essentially a platform to allow software to thrive on top, rather than hardware which is specifically built for a specific application. It's different, but they need to work hand in hand, of course.
What do you think, Raman?
Yeah, it's obviously partnership between hardware and software. That's the only way to go.
Yeah, so I mean, it sounds like everyone's sort of in agreement that it's a software and hardware partnership that's going to have to, be the thing. I want to thank you all for joining us here today. I'm really personally very excited about what it means to bring together these hardware and software communities and just, see the kind of innovation flourish. I really think, it's going to be a wild ride over the next couple of years as all this kind of happens. Looking forward to seeing how each of your companies sort of progress. I want to thank everybody for joining us.